Okay, chapter 8 is about limits and continuity. Right, so first part, okay, 8.1 is about limits. Okay, what is limits? Okay, limits is a topic that we learn about. We want to know what happened to a function, okay, when x is approached to a number. For example, we want to know what happened to the function fx, let's say x squared. Okay, want to know what happened to fx when x is approached, let's say 0, right? So here comes the word limits. Okay, want to know the limits of fx when x is approached 0. Okay, so we want to know what happened to function fx. If we know the graph, okay, we already know, okay, the function for fx, okay, this is x squared. Okay, when x is approach 0, okay, from either side, okay, either from left or right, we know that the graph for f is approaching to 0. Alright, or the easiest way is we just substitute what happened when x is equals to 0. So that is 0 squared, which is 0. Alright, so that's what is limit. Okay, so basically limits is just substituting the value of what's the value that it approach. Okay, if x is approach 0, so we just substitute 0. Okay, so that is the basic. Okay, so remember, limits is just substitute. Alright, so we look at first example here. Alright, so we want to find the limit of x approach 3 for the function we have here is 5. So what we just talked about earlier, okay, for a limit we just substitute, okay, the value that x is approach. So here x is approach 3, so we just substitute x with 3. But in this function we doesn't have x, so what we want to do? So if there are no x, so we don't need to substitute, so the limit is just x, is just 5. Okay, so the answer here is 5. Or we can say that limits of any constant is that constant itself. Alright, so b, limit of x approach 3 for the function 1 over x minus 1. So we remember, limits is just substitute, so we substitute 1 over, okay, the x is approach 3, so we substitute x equals to 3, so 3 minus 1, so this is 1 over 2, so we get the limit which is 1 over 2. Alright, so c, limit of x approach 2 for x squared plus 1 over x squared minus 1. Alright, so we just substitute. Okay, very easy. We just substitute. So x equals to 2. So 2 squared plus 1 over 2 squared minus 1. Okay, so this is 4 plus 1 over 4 minus 1. So this is 5 over 3. Alright, so we get the limit which is 5 over 3. Okay, d, okay, limit of x approach 9 for this function, so we just substitute x equals to 9, so square root 9 plus 2 over square root 9 minus 2, so this is 3 plus 2 over 3 minus 2, so this is 5 over 1, or this is 5. Alright, so that's very easy. When we have a question about limits, what we do, we just substitute the value of x. Okay, very simple. Alright, so we have another 2 question here, so you can pause the video and try by yourself, and then you can continue. Alright, so e, limit of x approach negative 2 for this function x squared plus 3, so we just substitute x equals to negative 2, so we have negative 2 squared plus 3, so this is 4 plus 3 equals to 7, so the limit is 7. And then the last one is x approach 3, so we just substitute Okay, x equals to sert 3, so sert 3 power 4 minus 2 sert 3 plus 4 over sert 3 power 2 plus 3. Alright, so sert 3 power 4 is just 3 squared, which is 9. So 9 minus 2 sert 3 plus 4. Over here we get, okay, 3 plus 3, which is 6. So up here we have 13 minus 2 sert 3 over 6. So this is the limit. Alright, so limit is very simple. We just substitute. So remember, for limit, what we do, just substitute. Okay.